Hello students, welcome back to my YouTube channel ADM JE Academy. So in the previous video we have discussed the MCQs which are provided by the Government of Karnataka for your board exam, second PUC board exam. We have completed 30 questions. Now in this video we will continue solving those questions. Question number 31. Let f from R to R defined by f of x equal to 2x plus 6, which is a bijective mapping. Then f inverse of x is given by, you have to find the f inverse of x. Okay, so f of x is given. F of x is nothing but what? Y, right? F of x is y, 2x plus 6. So express this equation in terms of x. Take this 6 to LHS, it becomes y minus 6 is equal to 2x. Send this 2 to LHS, it becomes y minus 6 divided by 2, which is equal to x. Okay, this can also be written as x equal to y by 2 minus 6 by 2 is 3. Y by 2 minus 6 by 2 is 3. What is this? This is nothing but f inverse of y, right? F inverse of y is y by 2 minus 3. But what we need? We need f inverse of x. F inverse of x. Just to replace x in the above equation, that is x divided by 2 minus 3. So option A is the correct answer. Okay, next, if the set A contains 5 elements and the set B contains 6 elements, then the number of 1 1 and onto mappings from A to B. See here, you can observe that let n be the cardinality of A and m be the cardinality of B, right? N is not equal to m. N is not equal to m. Whenever n is not equal to m, then the number of 1 1 and onto functions is always 0. If n is equal to m, if n is equal to m, then number of 1 1 and onto functions is either it is n factorial or it is m factorial, since both are equal. Okay, that is the key point you have to remember. Okay, this is the key point, right? Next question, let A equal to this set containing 1 2 3 so on up to n, and B is the set containing only 2 elements AB. Then the number of surjections from A into B. Surjections means what? It is onto functions. You have to find the number of onto functions. Okay, so total number of functions. How to find the total number of functions? You know that, right? Total number of functions is given by 2 power cardinality of the set A. Okay, 2 power cardinality of the set A. What is that cardinality of the set A? Here that cardinality of set A is n, 2 power n. Next, this is total number of functions. Total number of functions. Why we are taking total number of functions as 2 power n? See here, in the set A, you have 1, 2, 3, so on n. In the set B, I have 2 elements A, B. So if I want to map 1 to any of the element, it has how many choices? It has 2 choices. Either it can be mapped with A or it can be mapped with B. Similarly, 2 can be mapped with A or it can be mapped with B, right? Or 2 can be mapped with A or B. Similarly, 3 can be mapped with A or B, right? So each element in the set A have how many choices to get mapped with the elements of B? It is 2. Okay, that's why we are getting 2 power n here. Total number of functions as 2 power n. Okay, one has 2 choices, 2 has 2 choices, right? 3 has 2 choices, 2 choices. Similarly, n has how many choices? 2 choices, right? So if you want to add all these, what it is 2 into 2 into how many times it is repeating, n times, so it is 2 power n, 2 power n, that's why it is 2 power n. Okay, this is total number of functions, but they are asking onto functions, right? So in total number of functions, if we subtract the functions which are not onto, then we'll get the number of functions, yes or no? If we subtract the number of functions which are not onto, then I'll get a total number of surjections, right? So yes, it is given by, for example, here I have 1 2 3 and so on, n, a, b, this is a, b, right? So there are two choices, because if all the elements of a are mapped to a only, okay, or else if all the elements of a are mapped to b only. If it is mapped to a, this b is left, right? If it is mapped to b, then a will be left out here. So totally how many such possible cases are there? Two cases are there, right? Therefore number of surjections is, in the total number of functions you are subtracting the functions which are not surjective. Okay, it is nothing but 2 power n minus 2. So option b is the correct answer. Next question, if the set A contains 5 elements and the set B contains 6 elements, then the number of 1 1 mappings from A to B. You have to find the number of 1 1 mappings from A to B. Okay, how do you find number of 1 1 mappings? It is given by the formula npm. Okay, this is n of b is equal to n of a is equal to m. Therefore number of 1 1 functions and onto function 1 1 functions is given by npm. It is nothing but here 6p 5. It is nothing but 6 factorial divided by 6 minus 5 factorial. If you calculate this, you are going to get a 720. So option E is correct. Next, if A contains 5 elements and the set B contains 6 elements, then the number of onto mappings. Okay, they are asking onto mappings. Here you can observe that n of A is less than n of b, means elements in the codomain are less than elements in the domain are less than the elements in the codomain. So I cannot make a onto function, yes or no? So number of onto functions is 0. Let n be, next question 36, let n be the set of natural numbers and the function f from n to n be defined by f of n equal to 2n plus 3 for all n belongs to n. Then f is, you have to say whether the given function is surjective, injective or bijective. Okay, so let us find out whether it is 1 1 or not, injective or not. Okay, how do you find injective? That is f of n1 is equal to f of n2 must imply n1 is equal to n2. Okay, so find it out. F of n1, it becomes 2 n1 plus 3 is equal to f of n2 is 2 n2 plus 3 plus 3, here also plus 3 gets cancelled. 2 n1 is equal to 2 n2, this gets cancelled, so you are getting n1 is equal to n2, right? So f is 1 1 function, f is 1 1 function, it is injective. Okay, next we'll check it for surjective. Surjective means, here see, it is n to n. Observe the codomain. Codomain is n, means all the elements in the codomain must have a preimage. If I write the range of this function, when you put n equal to 1, it is 5. Okay, when you put n equal to 2, it is 7. When you put n equal to 3, it is 3 to the 6 plus 3. It is 9. So we are getting only odd numbers, right? Odd numbers in the range. Means remaining even numbers and the numbers which are less than this. Odd numbers which are less than 5. They are all not having a pre-image, right? So it is not surjective, right? So it is only the injective function. Okay, next question. Which of the following functions from z to z are bijections? Bijection means 1 1 and onto. First question, f of x equal to x cube is there. We have to check whether it is 1 1 and onto. Okay, so you can check it for 1 1. It is 1 1 because x1 cube is equal to x2 cube. F of x1 equal to f of x2 means it will imply that x1 is equal to x2. Then what about onto? Okay, we have to check whether it is onto or not. For example, I have here y is equal to x cube, right? Taking cube root on both sides, I will get x equal to cube root of y, or when you put y is equal to 2, when you put y is equal to 2, so here you are getting cube root of 2. Yes or no? When I am taking y as 2, you are getting the x value as cube root of 2, which does not belongs to the integer. So this is not the bijection, right? Next, f of x is equal to x plus 2. Here you can see x1 plus 2 is equal to x2 plus 2. So it is x1 is equal to x2. It is 1 1. Onto, whether it is onto function? Yes, it is onto function. See here, because if you substitute any value for this x, you are going to get a integer, right? Any value in the codomain. For any value in the codomain, right? Put any value of x, you are going to get again the integer. Yes, so it is onto function. It is both 1 1 and onto. So it is bijective function. Okay, what about this 2x plus 1? Okay, 2x plus 1 is there. If you put okay, 2x plus 1 means it is 1 1 function. You can prove that. Then what about onto function? Onto function, you will be getting y is equal to 2x plus 1. Then if I put x is equal to y equal to 2, I am taking y equal to 2 here in this equation. So what I will get? 2 minus 1 is equal to 2x. X equal to, it is 1 divided by 2. It does not belongs to the integer. So it is not surjective. Okay. So again it is 1 1 but not 1 2. Next, f of x equal to x square. See, it fails for 1 1 itself because x square is there. If you put minus 1, you will get a minus 1 square value as 1. Plus 1 square value is also 1. Means 2 elements are related to single element. So it is not a 1 1. Okay, so option B is the correct one. Next question, let f from R to R be defined by f of x equal to 3x minus 4 is invertible, then f inverse of x is given by. So this you can do it as a homework. Okay, this is homework. We have solved the question number 31. It is similar to 31. Okay, so we will get the answer as option A. Next, 39. Let S equal to A, B, C is the set A, B, C, and T is 1 2 3, set containing 1 2 3. Which of the following functions from S to T f inverse exist? Okay, f inverse should be exist, means it should be 1 1 and on 2, right? See this option, option B, A is related to 1, B is related to 1, C is related to 1. All these three are related to 1. So it is many 1. It is not 1 1. So this option is wrong. Similarly, again 1 is related with the 2 elements. This option is wrong here also. Yes. So which one is the correct? Option A is the correct. Next, find the number of all 1 functions from the set A, which is equal to 1, 2, 3, 4 to itself. A to A you have to find out. F from A to A, that too you have to find 1 functions, right? So 1 functions is given by N, P, M, right? What is N? N is cardinality of this codomain. M is cardinality of the domain, right? It is 4P4. If you calculate this, 4 factorial divided by 4 minus 4 factorial, which is nothing but 4 factorial. How much it is? It is 256. Next question. Statement questions. Okay. First statement. A relation R which contains 1 comma 1, 1 comma 2, 2 comma 1 defined on the set A 1, 2, 3 is transitive, right? They are telling it is transitive. Transitive means it should be reflexive, right? 1, 1 is there, but 2 comma 2, 2 comma 2 is not there, right? And 3 comma 3 is also not there. So statement 1 is false. This is false. Okay. Then what about statement 2? A relation R on the set A is transitive if A comma B belongs A comma B and B comma C belongs to R, then A comma C belongs to R. Yes, it is true. Statement 1 is false, but statement 2 is true. Okay. Next question. Let F is defined from the set 1, 2, 3 to the same set 1, 2, 3 is a function if F is 1, 1, then F must be onto. If F is onto, then F must be 1, 1. Right? So what is the first statement? F is 1, 1, then F must be onto. 1, 1 means you can write 1, 1 function, right? 1, 2, 3. Here also it is 1, 2, 3. 1 is related to 1, 1 is related, 2 is related to 2, 3 is related to 3, or else 1 is related to 2. It is 1, 1. It is understood, right? Means every element of the codomain are having pre-images. So statement 1 is correct. If it is 1, 1, then F must be onto. Next, if F is onto, then F must be 1, 1. See, F is onto, they are telling, right? 1, 2, 3. Here it is 1, 2, 3. Onto means every element in the codomain must have a pre-image, right? So either 1 can relate to 2, 2 can relate to 3, 3 can relate to 1. Then it is 1, 1 function only. You can arise a doubt that 1, 2, 3, 1, 2, 3. Why can't we take 1 is related to 1 itself and 2 is also related to 1 itself, right? 1 is related to 1, 2 is related to 1. Here they are telling it is onto function, means every element in the codomain must have a pre-image, right? So 3 may be related to this. So here 2 is left over, right? So it is not a function. Yes or no? It is not a function. So statement 2 is also correct. Both 1 and 2 are true. 1 is true, 2 is also true. Next, question number 43. Let f from R to R defined by f of x equal to 3x is bijective. A function, and that is first statement. A function f from A to B is bijective if f is 1, 1 and onto. Okay, we have to see whether this function is bijective or not. Okay, see, f of x1 is equal to f of x2 must imply x1 is equal to x2. So it is 3x1 is equal to 3x2, right? 3, 3 gets cancelled. You are going to get x1 is equal to x2. Means it is a 1, 1 function. What about onto function? Let y is equal to 3x, which implies x equal to what? X is a y by 3. Now substitute this x value in the given function. F of x is 3 into y by 3. X value is y by 3. This gets cancelled. which is equal to y. So we are getting f of x is equal to y, which means it is onto, right, one function and onto functions. Hence it is bijective. Statement 1 is correct, right? And statement 2 is also correct, which is the definition of bijective function, right? So option B is correct. 1 is true and 2 is true. 2 is correct explanation of 1. Next, statement 1. Consider the set A 1, 2, 3 and R with the smallest equivalence relation on A. Then R is an identity relation. Smallest equivalence relation they are asking, right? We know identity relation. What is identity relation? If every element of the set A is related to itself, then it is called as identity relation. No other pairs should be present over there, right? So 1 comma 1, then 2 comma 2, 3 comma 3. Yes, if I add any other element, right, this is already equivalence relation. It is already a equivalence relation. If I add any other element, then it will be, then for that pair we need to make symmetric and transitive condition, right? So this is the smallest set and it is called as identity relation. It is identity relation. Okay, statement 1 is correct. Then R is an equivalence relation, then R is reflexive, symmetric, transitive. Yes, so option B is correct here. Okay, next, assertion reason type questions. Assertion is, in set A 1, 2, 3, set containing 1, 2, 3, a relation is defined 1 comma 1, 2 comma 2 is reflexive. They are telling reflexive means 3 comma 3 should be there, no, which is not there, right? 3 comma 3 does not belongs to R. So assertion is wrong. A relation R is reflexive in set A if A comma A belongs to R for all A belongs to A. Yes. So reason is true, but assertion is false. So option D is the correct one. Next, 46. Assertion, in set A 1, 2, 3, the relation R in the set A given as R equal to the singleton set which contains only one ordered pair 1 comma 2 is transitive. Yes, in if a relation contains only one ordered pair, then it is always a transitive relation. Okay, a singleton relation is transitive. So here both are true. A is true, also R is true. Okay, next. Okay. Yes, next question. 47. Assertion is, if n of A is 3, then the number of reflexive relations on A is 3. See, n of A they have given, right? You have to find the number of reflexive relations on this set. Yes or no? So number of reflexive relations is always given by 2 power n into n minus 1, where n is the cardinality of the given set. So it becomes 2 into 2 power 3 into 3 minus 1, which is nothing but 2 power 3 into 3 minus 1 is 2. It is nothing but 2 power 6. What is 2 power 6? It is 2 into 2 into 2 into 2 into 2 into 2. This is 4, 4, 4, 4 cube, right? But they are mentioning it is 3. So which is a false statement. Assertion is false. A relation R on the set A is reflexive if A comma A belongs to R for all A belongs to A. So A is false, but R is true. Option A is the correct answer. Next, 48. Assertion A is given by a relation R which contains the ordered pairs A, comma A, B, comma B, B comma C comma C defined on the set A, B, C is symmetric. They are telling it is symmetric. See here, B comma C is present, but C comma B does not belongs to R. So assertion is false. A relation on the set A is symmetric if A comma B belongs to R, implies B comma A belongs to R. Yes, reason is true, but assertion is false. Option B is correct. Next, 49. Statement 1. The function f from R to R defined as f of x is equal to 0 if x is a rational, 1 if x is a irrational. Right? All the real numbers are there. All the real numbers. Minus 1, 0, 1, 2 and so on. Here also. Minus 1, 0, 1, 2 and so on. Right? But here they have defined the function like if x is rational, 0. Okay, if x is rational, f of x is 0. If x is irrational, then it is 1. Means if we have any irrational numbers, it is related like root 2, root 3, they are all related to 1. Okay, and remaining all the irrational rational numbers are related to 0. Right? So only 0 and 1 are having the pre-images, whereas remaining elements in the codomain, they do not have a pre-image. So statement 1 is wrong. It means it is not onto function. So it is not a bijective. A function is said to be bijective if it is both 1, 1 and onto. Yes. Statement 2 is true. 1 is false. 2 is true. 49. Option B is correct. Next. 50. Statement 1 is a function f from a to b cannot be an onto function if n of a is less than n of b. It is true, right? Number of elements in the domain are less than number of elements in the codomain, which means some elements in the codomain do not have a pre-image. Okay, yes, so it is true statement. Statement 2, a function f is onto if every element of codomain has at least one pre-image in the domain. Yes, statement 2 is also correct, and it is correct explanation for the statement 1. Next, consider the set A containing 3 elements, then the total number of injective functions from A onto itself. Injective functions from A to A we are going to find here. Okay, injective function is nothing but 1, 1 function. What is 1, 1 function? Number of 1, 1 functions. It is given by n, p, m. N is cardinality of a codomain and m is cardinality of a domain. So it is nothing but 3 p 3. If you calculate this, you will get the answer as 6. Next, 52. Question number 52. It is a set has 3 elements and B has 4 elements. The number of injective mappings. You have to find the injective mappings that can be formed from A to B. F from A to B. You have to find the injective functions. Cardinality of codomain is 4. Cardinality of domain is 3. Again, injective function is nothing but 1, 1 function. It is given by n, p, m. 4p 3. If you calculate this, you will get a 24. That is 4 factorial divided by 4 minus 3 factorial. So you will get a 4 factorial only. It is nothing but 24. Next, 53. Let A is the set 1, 2, 3 and B is the set A comma B. Then the number of surjections from the set A into B. See, B has 2 elements, A has 3 elements. You have to find the on two functions. So first let us find the total number of functions. Total number of functions. Have one can map with the 2 elements. So it has 2 choices, right? One can map with the either A or B. One has 2 choices. We have done this previously. 2 has 2 choices. Like similarly, N has 2 choices. So number of functions, total number of functions will be total number of functions is equal to 2 power n, right? 2 into 2 into 2, so it is repeating n times, so total number of functions will be 2 power n. We need surjections, so in the total number of functions we are going to subtract the functions which are not surjective. So which are not surjective here? There is two chances, right? All the elements of A can be related to B. All the elements of A can be related to A. So two choices are there. So it is nothing but 2 power n minus 2. Not here, it is not here because this is total number of functions. Now number of surjections. Surjections. Number of surjections, that is equal to 2 power n. What is n here? Cardinality of A. 2 power 3 minus 2. If you calculate this, you will get 8 minus 2, that is 6. Next question. The number of equivalence relations containing 2, 1 on the set A equal to 1, 2, 3 is. Okay, so this is similar to question number 15. Question number 15 we have solved, right? It is similar to that. You can go through that question. Okay, it is in the first part of the video. Okay, you can go through that. Answer for this will be 2. Next question. A contains 4 elements and B contains 5 elements. Then the number of onto mappings. Cardinality of A is less than cardinality of B. Means onto functions. Some elements of B do not have what? Free images, right? It means number of onto functions will be 0. 4 is less than 5, right? Cardinality of A is less than cardinality of B, then no onto functions. No onto functions. Okay. So only these many questions in this video. In the next video, we can continue the remaining questions. If you have any doubts on all these 55 questions, you can mention that in the comment box. Okay. Thank you for watching my video. Okay. Thank you.